So today we're going to look at this here, 100% argon gas, a little bit over 40 CFH, and we're going to be comparing the HTP spool gun. It's about a $500 item that hooks up to your MIG 1400 or 2000i versus just the regular MIG gun that is designed for aluminum with a drive roll that is designed for aluminum. So your settings are the same in the door chart either which way. If in both cases we used 4043 aluminum, 035 diameter. In both cases we used some 1/4 inch and some 1/8 inch metal. Yes, it's a different wire manufacturer just because I wasn't able to get the exact same wire manufacturer in the small 4-inch roll and the bigger 8-inch roll. But it's the same alloy, same diameter, same gas tank, same machine, same everything as far as I know. And we're taking a look at, does the spool gun for $500 offer you any benefits? Does it weld any nicer? Or is about a 200-ish, a little bit more, but bottom line half the price setup where you have a MIG gun with a carbon graphite liner and an aluminum drive roll? Is that the better option for you? So let's dive into this and see what happens. Now we have two pieces of aluminum. We have some 1/4 inch here we're going to be welding later on. We're going to start off with some 100,000s. 100,000s is right in between 14 gauge and 1/8. So we're going to pick 035. We can either pick the 1/8 because we have the thick work table as the heat sink under it. Then we just need to move faster than normal. So we would be right here at 18.5 volts and 375 inches per minute. 375 inches a minute and 18.5 volts. So let's see how that works. So by the soot you can see my gun angle was not perfect. If my gun angle would have been perfect and the gun would have been up a little bit more, we should have had equal soot on both sides and a little bit less. I had a little bit shallow of an angle here, so the soot is only on the back side, not on the front side. Little bit peppering in there, not too bad. That is because we did not clean any oxides off or prep anything. But now the truth comes looking at the back side. Full penetration weld. No cracks in it, and the table as a heat sink did its job with the slightly too high settings. It kept all the material contained. So now let's do the same thing on 1/8 material thickness. What do we have there? 375, 18.5. So yes, 375, 18.5. You got to pay attention when you read those charts. It's so easy to jump a line there. But anyhow, we're going to set the machine to that. We're going to do the same exercise. We're going to do the same T-joint, weld the front side with the original settings, and then weld the back side with the same original settings and totally annihilate it and see what happens if you don't follow the advice that I'm trying to show you. Aluminum is a very thermic driven process. It's all about the heat input. To see how good or bad a weld is, the front side will only tell you less than half of the story. You flip it over, look at the back side, and it will tell you the whole story. Now when you listen to this and you say, there's still a little bit popping in there, I agree, this could have benefited from another 0.3, maybe 0.5 volts to get the arc just right. But I didn't. I mean, this is the settings for the door chart, and it got me really close. And you see that the second run here, the crackling is already less because the material is preheated. So the front side, maybe a smidge too cold. Again, that 0.3, 0.5 volt more, it could have stood that. A little bit less crackling, it would have wetted out a little bit nicer. But typical spool gun fashion, it's a good commercial weld. There's nothing really wrong with it. On the back side, holy moly, look at this. Absolutely concave, black, and it got so hot that it cracked entirely through the parent metal. I mean, there's no saving this at all. That is the risk you run overheating your aluminum. You see the first side on the top had just the right amount of penetration. It wasn't really a weld that was too cold. The second one just totally blew right through it. On that quarter there, it could have stood a little bit slower welding speed to push through a little bit more, but overall, not bad. So now the next step is using the same wire, 4043 035, all the way up to 1/4 inch, 490 inches per minute at 23 volts. Same thing here. We are not going to have proper joint prep, but we do have a shear cut piece of metal here that has like a little bit of a V-groove like right on there. So we're gonna use that V-groove to create somewhat of a bevel. We're teeter-tottering on some BBs on here. The ground clamp is not on the part as it's supposed to be. And the table will act as a heat sink, even though we have welded on it. It's warmed up a little bit, but not enough to worry about it. So we're gonna weld this with aluminum. It's going to be a spray arc. All you should hear is a hiss, no crackle, no pop, and it should be one smooth operation. Your contact tip to work distance is supposed to be about 3/4 of an inch. So let's see how that works. So you can tell my gun angle was a little bit better. There's actually some soot on this side. And also you have a little bit of a cold start, and you heard a couple pops in the beginning. Maybe it could have taken another 0.3 volt or something. This is you, the operator, depending on what alloy you're welding, what wire you're using, if you have a heat sink under it or not. If this was propped up on some TIG rods, I'm pretty sure it would have been hot enough. The heat sink here pulling the heat out, it could have used a little bit more voltage. This is 3003 material. Different base alloy requires different small adjustments. Then it heated up really nice, and at the end there's a very minor crater. You could have triggered it a couple more times and filled that crater. And now moment of truth. Backside, you don't really see much at all. It kind of looks like there might be some coming through here, and at the end you see a small deformation there. If you wanted to get 100% weld, if this was a critical item, I'd probably go in with a hard wheel designed for aluminum, grind this out a little bit till I see the other side, the root, and then weld it and fill it in. In that you just got from the charge, press your button to activate the spool gun. 1/4 inch, and right there, 490 inches a minute, 23 volts. Put those settings in the front. There was your wire speed, Now that you touch the voltage knob, the display switches over to voltage. Now let's load a roll of wire and we're good to go. Now, as you can see, I have a little bit of an unconventional approach there. I never really open it and run it through the drive roller. I straighten a piece of wire out and then under throttle, pull the trigger, run it right through. So this was the back side here. Of course, it was a little bit too hot, as you can tell. Flipping it over, looking at the front side. And yes, that's absolutely more like it. Those are the results you're used to see. You see, typical spool gun fashion, the start, the first 3/4 inch a little bit cold, and then all of a sudden it welded like the way it's used to. This is 1/4 inch material, 035 wire. So the first time around, I didn't exactly like the way how it was welding. I mean, it was nice, but I wasn't used to everything. That was the first weld I ever did with that spool gun. So now there's another 1/4 inch coupon, 4043 aluminum wire, 035, same settings as last time. And you can hear just how the arc runs, that it's so much smoother. And it just does what it's supposed to do. And this right here is the biggest no-no of all times. You can't just weld the backside and expect a decent result. Now your coupon is preheated. Your settings are way too hot. I didn't let it cool down. I didn't lower the settings. So you will see when I show you the pictures on how this actually looks like and why you never really want to do this. Front side looks absolutely immaculate. Backside just destroyed, absolutely concave, peppering in it. You can tell it's way too hot. So thank you for sticking it out so long and watching our demonstration on the new MIG 2000i. If you don't have 220 at home and you only have 110, the little brother, the 1400i, is basically the same thing, less power, runs off of 110 only, but same features, same. So let's see, did you like the spool gun welds better, or did you like the regular push gun welds better? Leave a comment, like, subscribe, and I will see you on the next one. Thank you. Bye.